Hey guys, hope you are great. So in today's video we are going to discuss the binomial expansion, how to determine the independent term. So independent term in the expansion. So take for example, we have been given to come up with the independent term in the expansion of x minus 1 over x to the power squared to the power 6. So let's say we have been given this question to come up with the independent term in the expansion of that. So now, under coming up with the independent term, in as much as we want to come up with the independent term, in other words, we are looking for a constant term in this expansion. So we are looking for a constant term in this expansion. So in this case, let me say we are going to apply this formula: n combine r a n minus r dot d to the power r to come up with the independent term. So in this case, we have 6 combined. So in this case, we don't know the term position, which is term position in r. We don't know this. So in this case, we have n combined r. We are looking for r. Where is it exactly? Where is our independent term? Where is it? So we have 6 combined r x. We have 6. We have got 6 minus r. 6 minus r multiplied by our b in this case is negative 1 over x squared to the power r. So in order to evaluate this, we are saying we have 6 combined r multiplied by x 6 to the power 6 minus r. So on top, I'm going to split this. I'm going to separate this. So on top we have got negative 1 combine r. Let us distribute the r throughout. Then at the bottom we have got in this case, this is just multiplication. So when a power is raised to another power, we must multiply the powers. So in this case, we are getting x to the power 2r. So now, to come up with the independent term, let me express this mathematics very well. So in other words, we have got 6 combined r multiplied by x to the power 6 minus r. Then we have got a negative inside this to the power r. A negative inside the bracket to the power r. Then on this, it is where I'm going now to put x to the power 2r, so that we see what happens to this whole thing raised to the power to this whole thing where x is raised to a power in terms of r. So now what we have is we have x here is common. So now we're saying when x when dividing indices having the same base, we must subtract their powers. So in this case, what I'm looking for I'm looking for the condition where I'm going to cancel this whole thing in terms of x completely, because what we are looking for a term which is independent of x. So meaning at no point should we expect to have anything raised to the power anything in terms of x. So we want to eliminate this thing in terms of x completely. So in this case, what we are going to do is we are going to take advantage of these powers, since we know that for us to cancel this it's a matter of now these powers now they must be equal. they must be equal, or when we use the rules of indices of subtracting the powers for the indices having the same base, it's one and the same thing. So in this case, what we are going to get is we are going to get um, this x, which is x to the power 6 minus r divided by x to the power 2r. So in this case, what we must get is we must get x um, 6 minus r. We are subtracting this because we are dividing. We are dividing, so minus 2r. This is what we must expect. So in this case, the O of this, 6 minus r minus 2r. We are saying we don't want to have x in our expansion in that term. That is what is meant by term independent. So the O of this must be equal to x to the power 0. So this and this must go. So we are remaining with 6 minus r. In other words, let me just say 6 minus 3r is equal to 0. So when we solve for r, we must get r is equal to 2. So in this expansion, we do have the term independent when r is equal to 2. When r is equal to 2, that's where we have now the independent term. So now let us get to evaluate this independent term. So we say this independent term is simply 6 r. We now know r is 2 multiplied by x. So in this case, let me show you now how this x is going to be cancelled out. So we say 6 minus 2 over we do have x 2, the value of r there is 2. The value of r there is 2. I'm reminding you this. So the value of r there is 2. So let's go back. So the value of r there is 2. Let me write this properly. So the value of r there is 2. So multiplied by. So I had to include this negative 1 in my expansion because it determines the sign that I'll get for my answer. So in this case, this one, the one in bracket was raised to the power r. So you now see how important it is. So we know that 6 combined 2 is the same as 6 factorial divided by, so we say 6 minus 2 factorial, then 2 factorial, multiplied by, we know that 6 minus 2 is 4. Then here 2 times 2 again is 4. So we have, in short, we are getting this x over x to the power 4 divided by x to the power 4. So this will be cancelled out. So you now see what I was trying to demonstrate. So I want to demonstrate that this is going out. So this is going out. So again, 2, negative 1 to the power 2 is just 1. So in other words, what I'm getting is, I'm getting 6 factorial is just 6 times 5 times. I know that when I resolve this, it will give me 4. So I have to leave a power 4 factorial on top, since I have got a 4 factorial at the bottom times 2 factorial is just 2, because when I expand this I'm getting 2 times 1, so it is just 2. So the 4 factorial and the 4 factorial goes. So 2 into 6 is just 3. So what is 3 times 5 now? So 3 times 5 is 6. So it is 6. That is now the coefficient. So in other words, I'll put my answers: the term independent of x, the term independent of x. So when I have gotten when my value of r is 2, it means it is the third term. So where r is 2 is the third term. So in short, when you want to get the term, it is r plus 1. So it is r plus 1. So when you have got the value of r equal to 4, just know that it is the fifth term. When you have got the value of r, equal to equal to equal to 5, just know that you are talking about the sixth term. Yeah, because mind you, binomial will start from 0, 1, 2, 3. So whenever I've got the value of r equal to 1, then I'm talking about the second term. Whenever I've got the value of r equal to 2, I'm talking about the third term. So that's so and so forth. So in this case, I'm saying. So in this case, I'm saying the term independent of x. So term independent is equal to. So it is the third term since the value of r is equal to that, and it is equal to 6. So that is my answer. So that's how we do it. So now, let's say again, there are cases when you'll be given, let's say you will be given a very complicated problem. Let's say you have got a very complicated problem. Let's say it is raised to a power which is a very large number, and they ask you, let's say, to look for the to look for the to look for a term for a term. You have to look for a term. Let's say in the expansion of they have given you like you have got 2x minus 3 raised to the power let's say 11, and you are asked to come up maybe with a 9th term. So dear colleagues, I want to tell you that you don't need to expand the whole of this, but with the knowledge that you have, you know that the 9th term is where r equal to 8. So with that knowledge, you say it is simply 8 combined. I mean, not 8, but 11 combined 8 multiplied by 2x to the power. What is 11 minus 8? So 11 minus 8 is just 3 multiplied by negative 3 to the power 8. So you start reducing this. You know that 11 combined 8 is simply 11 factorial divided by 11 minus 8 factorial. Then we do have 8 factorial as well, multiplied by what else do we have? We have got 2x to the power 3. 2x to the power 3. So 2x to the power 3 is simply 8. Then we have x to the power 3 as well, because the whole of that thing is being affected by the power. So again, we do have what is 3 to the power 8. So what is 3 to the power 8? So what we are going to do is this. So negative 3 to the power 8 is so negative 3 to the power 8. Okay, let me do a simplification here. So negative 3 to the power 8 is just the same as saying. So you will not be using calculator. So we must have strategies on how to reduce this. So we are saying it is simply negative 3 to the power 4 multiplied by negative 3 to the power 4. So now, what I know is that negative 3 to the power 4 is simply 81. So it is 81. So I have to say what is 81 times 81. So 81 times 81 is just 1. I mean there 1 times 1 is 1. Then there it is 8. There it is 8. There it is 64. So what I must get is I must get 1. 8 plus 8 is 6. I carry 1, then I have got a 5, then 6. So it is 6, 65, 61. So it is 65, 61. So I've got here I've got 65, 61. And then what else did I have? Okay, that's all. Um, so let me get to rub this. Let me rub this. So that is what I get. So after that, say 11 factorial. 11 factorial is just the same as 11 times 11 times 10 times times 9 times 8. So divided by, I know that divided by 8 factorial. Um, so okay, let me use this to simplify 11 factorial. Then I've got 3 factorial because 8 minus 11 is just 3 factorial. Now 3 factorial is simply 6 times 8 factorial. So my 8 factorial and this will go. Then I've got 6 into, I mean 3 into 6 is 2. Then 3 into 9 is 3. Then 2 into 2 is 1. But 2 into 10 is 5. 5 times 11. So 5 times 11. I have to get 55. Yeah. I have to get 55. 5 times 11 is 55 times. Okay. Next, I want to do this. So I've remained with 11 times 5 times 3. So in short, what I must get is this. I must get, I've remained there with 11 times 5 times 3. So in short, I've got 55 times 3. What is 55 times 3? So I know that 55 times 2 is 110. So if I add 55, I must get 5, 6, and 1. So it is 165. It is 165 as it is. So let me go back to this. I'm going to grab this. So I have got 50. I have got 165. So even combine it is giving me 165 as a total. It is giving me 165. So I have got 165 there times 8, 8x to the power 3 times 65, 61. So what we get is equal to, so the all of this will be equal to, what is 165 times 8? What is 165 times 8? Let me get to grab this. So what is 165 times 8? So 165 times 8, what we get is, so we are getting 165 times 8, so we have, we do have 8 times 5 is 14, 8 times 6 is 48, so 48 plus 4, 48 plus 4 we must get 52, so 5 there, we carry 2. I mean, we get 2, we carry 5. Then 5 times 8 times 1. we get 8. Then 8 plus 5, we get 13. So we get 13 there. So we have got, so we are reducing this, sorry. So we have got 1320, 1320 x cubed times 65, 61. So let's get to multiply that. With mathematics. So they'll give you such a power. That's what they do. So most of the people do give up. They fail to reduce this. So once you understand what I'm doing, to make your life very easy in mathematics, to make your life very easy. So okay, it is 65 there. It is supposed to be 16. I mean 65, 65, 61, 65, 61 times 1320 times 1320. So we can reduce that. So if we multiply, we have zeros on top, zeros, zeros. There we have got a 2. There we have got 12. There we have got 12. 1 equal carry 1. So 3 times 5 is just 10. 10 plus 1 we get 11. We get 2 times 6. 2 times 6 is 12. 12 plus 1 we get 13. Again, we multiply throughout by, okay, where am I going to lab to write this correctly? Okay. Okay. Let me do this. So we have got 65, 60 times 65, 61 times 1320. So we are getting this. So here on top we have got 0, 0, 0. Then we have got 2. Here we have got 2 again, we carry 1. There we have got 10, so it's just like 11. So there we have got 6 times 2, that is 12, but we write 13 because of the 1. Then we have got 3 there. Then we have got, what is 6 times 3? It is 18. So 18 we carry 1. Then we have got 5 times 5 times 3 there is 15. So 15 it will be 16. 16 we carry 1. So there we have got 3. We have got 3. So this is a 0. We have got 3 times 6, that is 18. So we are going to write 19 there. Then we are going to distribute 1. So we are just getting the same thing, 6, 5 and 6 there. So when we add, we must get, what we are getting is we have got 0 there, it is 0. 2 there, it is 2. This is a 0. So 2 plus 3 is just a 5. Then we get this 1 plus 8 plus 1, that is 10. We just write a 0, we carry 1. Then 3 plus 6 plus 6 there is 6 plus 6 there is 12. 12 plus 3. 12 plus 3 is 15. 15 plus 1. So we get 15 plus 1 we get 16. So we carry 1 again. We have got 9 plus 5 plus 1. So or 1 plus 9 plus 5. So you know that there it's just 9 plus 6. So 9 plus 6 is 15. 15 plus 1, it is 17. 15, 15 plus 1 again, it is 16 because of the 1. Then you also have 1 plus 6 there. 1 plus 6 plus 1, we get 8. So the final answer that we are getting there, we are getting, so the final answer that we are getting there, we are getting 866. We're getting 866, 0, 0, 5, 20. 0, 5, 20 x to the power 3. So that is what the question demanded. So this is what we are going to be dealing with. So thank you so much for your time, and enjoy the rest of the video.